if you took the test on the day or whatever, it's graded and entered. Those are up. I'm gonna hold them for a couple of days till there's some people that still need to do a makeup or whatever till I get those in. But you can see your scores; they're available. Overall, pretty good. So, good job. Today, starting chapter 3. Gonna keep this day kind of chill. I'm gonna do like 20-30 minutes of me talking, then give you guys a chance to work on some practice stuff. Sound good? I like it. All right. So chapter 3 is going to be about graphing these trig functions. We're going to start with sine and cosine graphing. This lesson will run more than one day, but that's fine. So what you're looking at right here is the graph of y equals sine x. Notice that this graph is kind of like up and down, up and down, up and down, kind of like a wave. The shape we give for that kind of a graph is called a sinusoid. And so sine, which is this one on the left, and then cosine, that's this one on the right, are both examples of sinusoids. Any graph with that like wavy look is called a sinusoid. And if I look at the sine and cosine graphs, you're like, yo, Mr. Kulik, those look just about the same. The difference is like if I look at x equals 0, you know, like the graphs are in a different location, right? Now they're the exact same shape, they're just like one is shifted a little bit from the other, right? Okay. Today, all we're going to focus on is the key features for these sinusoids. So there's 3 key features that we're going to worry about today. Those 3 key features are the midline, the amplitude, and the period. We're going to talk about how we can look at a graph and figure those out, how we can look at an equation and figure those out, and then how we can go from a graph to an equation or a description to an equation. So it's just going to be like using these 3 key features, basically. So let's talk about what those things are. I'm going to do this just via example because I think it keeps everything nice and simple. We're just going to kind of use our eyes to do this. So the first one that I want to talk about is the midline. The midline splits your graph in half. So you have an equal amount of stuff above the midline and an equal amount of stuff below the midline. So for the graph of sine, that would be our midline. So everybody look at that and be like, yeah, okay, sure, I see that. Did I do anything to figure that out? Just use my eyeballs, right? So everybody's okay with that? Okay. Come on. There we go. The next piece we want to talk about is the amplitude. The amplitude, oh, come on, is just the distance from the midline to like an extrema, the maximum or minimum. So for example, like that's an amplitude. Or like this is an amplitude. I'm about sick of this. Does that feel okay to you guys? And what I mean by an amplitude? You could also think about it as, anyone touch anything? You could also think about it as like half the distance from a max to a min, right? I tend not to like thinking about it that way. I just use midline to extrema is usually the easier way to think about it. And then the third one was the period. So the period is like the short, I can't work like this. The period is the longest non-repeating segment. So you notice how the graph goes like this and just kind of repeats itself over and over and over again. So the easiest way to pick this out is to pick a starting point. Now, in a situation like this, I usually like to start at, if I can use x equals 0, and there's a good, come on now, a good landmark there, like I'm right on the midline. That's a good spot. And if I do like an up, and then I do a down, and then boom, I'm back to the midline, that's like one period. So the horizontal distance is what we're looking at there. That's what we mean by a period. So just like one of those segments of the graph, how long is that? Do we feel okay on what we mean by midline, period, and amplitude? Pretty straightforward, right? We're just using our eyeballs. I did no calculations, no formulas, nothing complicated. All right, let's look at a couple of examples. We'll do this exact same thing now on these couple of examples. So identify the midline, the amplitude, and the period. So this is another sinusoid. We don't know the equation for it, but it doesn't really matter. So let's look for the midline. We're just going to kind of use our eyeballs. And it looks to me like that's our midline, right? But do you agree with that? Looks like about the same amount above and below. So this is an equation for a line. So it starts y equals. And because it's horizontal, it's just going to be a constant. And because it goes through the y-coordinate 1, just y equals 1. Feel good there? Very easy to do, right? Nothing complicated. The next thing I'm going to do is look at my amplitude. So let's look at, say, this distance for my amplitude. Pretty good there. So I started at y equals 1, and it ends at y equals 4. So my amplitude is just big minus little, it's 3. Everybody like that? Mr. Kulik, I'm digging this. This seems pretty easy. It's not too bad. All right, next thing I'm going to do is my period. So I'm going to pick a starting point. Again, if I can, I'd like to start at 0 where it's easy to see. And then I did, like I do an up, I did a down, and then bam, back to the midline. That's my end. So we started at x equals 0, and we end at x equals pi. So again, big minus little, the period is pi. Does that feel okay there? Cool. So far, so good. We're all liking this. Pretty easy. Not too bad. Let's look at another example. So again, same kind of thing. Just going to use our eyeballs to figure this out. So if I look, it looks like maybe right about here is my midline. You guys agree with that? So if I look at the scale, so here's 0, here's 2, that's right in the middle, so that must be like y equals 1 then, right? You guys agree? Okay. We'll do our amplitude next. Whoop, whoop. So we started at 1 and we end at, well, that's this spot between 2 and 4. That must be 3 then, right? So we went from 3 to 1. So that amplitude should be 2. And then for our period, that'll be our start. So we did a down and then an up, and then we're back to the midline again. So we start at x equals 0, and we end at 4 pi. So my period is just going to be 4 pi minus 0, or 4 pi. You feel pretty good? Okay. What I want to do now is I want to say, okay, what if instead of having a graph, I just have the equation for a graph, like y equals cosine or whatever's. How can I figure out the midline, amplitude, and period just from looking at the equation for my function? Okay? So I'm going to give you guys this. So these are the general equations for a sinusoid. So the pieces that you care about right now is that, which is our general equation for sine. This one, which is our general equation for cosine. But even better than that is based on the numbers inside those general equations. I have the formulas to figure out the amplitude, the midline, and the period. You'll use this all the time. I would write that down, absolutely.
Should we write every single one? Or just the ones highlighted?
I would just worry about the highlighted ones for today. We'll circle back and do more. But again, my notes are in the content library, so it's not like you don't have it, too. You know what I mean?
Yeah.
It's just not in your notebook if you didn't write it down, which is not the end of the world, because you still have access to it at 24 hours a day. Well, as long as you have a charged tablet. So again, those are the pieces that really matter to us. So again, like I noticed that the A is just that comes from that leading coefficient out front. The K is that spot added on at the end. And that C is related to the coefficient on my X, right? So we're basically going to start by just looking at our equation, identifying the values for A, C, and K, and then plugging them into these formulas. So far, so good? All right. So let's do a couple of examples. So I'll write the general equation above it so it's easy to kind of see. So the first thing we're going to do is let's write down the values for A, C, and K. And then we'll plug them into the formulas after that. So if I look, okay, well, A is the leading coefficient. So for our problem, that's going to be -3. Feel good there? I'm going to skip C for a second. If I look here, K is the part that's added to the end. Well, so that's just 4. So far, so good. Now, the one that's a little bit tricky is that 1 over C is going to be that coefficient for the X. What does 1 over C mean? When I see 1 over, I think starts with an R. Reciprocal. So C is going to be the reciprocal of 3 over 2. So I'll write 2/3. Again, we're always going to be using that reciprocal there. I'm going to write that down to remind you that I got to do that. Very common mistake is for students to just write down the coefficient as C and not the reciprocal. Great. Now that I have my values for A, C, and K, I can write down the amplitude and the midline and the period by using the formulas that I gave you up above. So the amplitude, the formula was the absolute value of A. Well, A was -3, and the absolute value of -3 is just 3. So there's my amplitude. Now, Mr. Kulik, do I have to write down all this work when I do my homework? No. but these are notes. I'm going to write it all down. So it's like, if you go back and look at it, it's clear what I did. Obviously, if the amplitude is the absolute value, A is -3. Like, do I have to write? It's like, no, you just write down 3. It's fine. The midline is y equals k. And the k here is 4. And the period is 2 pi times the absolute value of c. So that's going to be 2 pi times the absolute value of 2/3. Well, the absolute value of 2/3 is just 2/3. Now, to multiply two fractions, I'll just think about 2 pi as 2 pi over 1. And we just multiply straight across. So 2 pi times 2 is 4 pi. 1 times 3 is 3. So my period should be 4 pi over 3. How do we do on that? Pretty easy, right? Not a big deal. But important skills, like let's build out these fundamental skills before we start layering the tricky stuff on top of it. Let's make sure we can do the easy parts. All right, we'll look at another. So again, I'm just going to write down the general form above so that it's easy to see for us while we're getting started. Not a bad idea for you to do for any problem is just start by like write down that general form so it's easy to remember like where's A, C, and K at. So again, we start the same way. Let's find that A. Well, that's 2. So A is 2. Yay! I think I did K next. Let's just keep my colors the same. So the K here is -1. Make sure we take our negative sign with us there. Even though it's -1 at the end, I'm going to take that negative with us with our K. And then our C is, well, 1 over C is going to be 2 pi over 3, right? The coefficient for X. But what's just C? It's the reciprocal, yeah. So 3 over 2 pi. Again, the C, we always do the reciprocal for that coefficient on X. Everybody feel good on figuring those? Okay. So my amplitude is going to be, who can tell me? 2, right? It's the absolute value of 2, so just 2. My midline is going to be y equals -1. That's just the K value. And my period is going to be 2 pi times absolute value of C. So again, the absolute value of a positive is just the positive. If I multiply these two together, what happens? Yeah, the 2 pi's cancel out. Good eye. And we're left with just 3. Does that feel good so far? What if we asked to do the reverse? What if we want to look at our graph and come up with an equation for it? So let's go back to these 2 graphs that we looked at just a moment ago. So what I need to do is I need to figure out the A, C, and K to put on my equation, right? So I'm going to use the midline that we figured out, the amplitude we figured out, and the period that we just figured out to fill in my values for A, C, and K. Sound good? All right. So the midline was y equals K. What does that tell me that the value for K is? 1. Okay. The amplitude we know is the absolute value of A. So what does A have to be? Not just 3. It also could be -3. Do we know which one is the right answer yet? No. We don't know which one to pick yet. Let's explain how I need to know. Okay? So to figure this out, what I'm going to do is I'm going to look at x equals 0. Okay, let me pick a better color than gray. Do that color. So I'm going to look at what's happening at x equals 0. If I look at my graph, I'm crossing the midline. In the situation where at x equals 0, I'm in the midline, I'm going to look at what's the first extrema after that. That first extrema is a maximum. That tells me the a should be positive. If the next extrema after was a minimum, then the a would be negative. The other option would be at x equals 0 that the graph is at an extrema. If it's at a maximum, the a should be positive. If it were at a minimum, the a would be negative. That's how I can tell. Everybody feel okay about that? Okay, so we know that from what we looked at above that the a should be 3. Oh my goodness. Do a better job here. Plus or minus 3 was equal to a. Okay. And then my period was, I know, is equal to 2 pi times the absolute value of c. So to solve this for c, I would start by dividing both sides by 2 pi, right? When I do that, I get 1/2. The pi's cancel, right? And I'm left with 1 over 2. And then absolute value of c, well, that's going to be plus or minus 1/2. Here's the nice thing about the c's. The way we're going to do this, we can just choose. What you should always choose is c to be positive. So for where we're at right now, and the way that I'm going to show you to do the more complicated problems, it'll always be possible to choose our value for c. We'll always just choose the positive. Now that we have all of this, we can say, okay, y equals a, and then I need to decide whether it's going to be sine or cosine, right? You know what told me that? Was that I was going through the midline at x equals 0. That tells me it's sine. If it was at an extrema at x equals 0, that would be cosine. So this sine, and I got that because at x equals 0, we're on the midline. Then we have 1 over c. 1 over c means the reciprocal of c. What's the reciprocal of 1/2? 2. You could write 2 over 1 also. That's fine. I'm just going to write 2. And then I have x, and then plus k. Now, in the general formula, we have this x minus h business. Not yet. We're not going to worry about any h's today. So anything that we're doing today, you can just assume there's no h in there. And then I just have the plus k at the end. Everybody's okay with that? We'll deal with stuff where h's come in, but not today. That makes things a lot more complicated. We're not going to worry about that today. We're just going to start with getting our feet wet. Let's do the other one. All right. So midline y equals 1 tells me that the k is 1. The amplitude is 2, tells me that a should be plus or minus 2. Let's figure out, yeah, sure, absolutely. Let's figure out if it should be positive 2 or negative 2. I start by looking at x equals 0. I'm on the midline. So I look at the next extrema after that, which is a minimum. So I pick negative 3. And then I know my period is 2 pi absolute value c is equal to 4 pi. What's up? Oh my goodness, absolutely. If you see a mistake, just shout it out. Don't let me keep going. Good job. I appreciate you paying attention. That's a big boo-boo. To solve this, we're going to divide both sides by 2 pi. What's 4 pi divided by 2 pi? 2. So C is going to be plus or minus 2, but we always choose the positive. That's everything we need. We just need to put it in together. So y equals negative 2. Was this going to be sine or cosine?
Sine.
Sine. How could I tell? Because at 0, we're on the midline, right? That's my checker. And then 1 over c, and then plus k. Not too bad, right? It's basically just doing the same thing, working backwards. The only tricky part is figuring out if A is going to be positive or negative. And that's not so bad. There's really just 4 options. All right. Next, what if I just give you a description of what the thing looks like? I don't actually give you the picture. I just say, okay, the thing has amplitude of 2, and the midline is 5, and the period is 3. Like write an equation from that, where I've taken away the picture. In a way, this is actually easier. You have a lot more flexibility because you're not tied to like, oh, it has to be going through these points or whatever. So the amplitude of 2, what is that going to tell me? Tells me about the A, right? So A is plus or minus 2. Now, if all I know is the midline and the period, can I tell whether that A needs to be positive or negative? No. You know what that means? We can write a sinusoid that meets these criteria with either a positive A or negative A. It won't matter. You can just pick. Oh, cool. Well, me, less things to write down better. I'm looking for that efficiency gain, so I'm going to pick the positive. Midline, well, that just tells me that K is 5. Cool. That's easy. The period, well, that's 2 pi times the absolute value of C. I'll just solve for C again. And just like A, it doesn't matter if I pick positive or negative because I don't have enough information to like, has to be one or the other. It could be both. So, what am I going to pick? The positive, of course. That's everything I need. Now, did it tell me that I have to do this as a sine or cosine? So guess what? Does it matter which one I pick? Nope. So I'll do 2. I'll just say for the sake of argument, I'll do a cosine this time. And then reciprocal of C, X, and then plus K. And I'm done. Like in a way, this is easier because there's a lot more flexibility. There's actually like, 4 sets of, or actually I should say 8 sets of correct answers. The 2 in front could be positive or negative. The function could be sine or cosine. The C could be negative or positive. It's like 8 choices that are all correct. That ain't bad. That's it. That's all the stuff I worry about today. You guys are going to work on a delta math as practice for this. Let me just show you what those problems look like. So it's chapter 3, delta math number 1. So I ask you to determine the period. So what part's going to tell me the period? I need the C. So this is 1 over C, right? So C is 1 over 2 pi. And I just multiply that by 2 pi in my formula. So I get the answer is 1. Bloop. Again, you probably need to write stuff down. Totally fine. You should be writing stuff down. If you're a math teacher, you wouldn't need to be in this class, and you could do it all in your head. But this one you could do in your head, though. Just wants the equation for the midline. What does it look like to you guys? Looks like -1 to me. What do you guys think? Now be careful here. You must type y equals -1. If you type -1, it'll mark it wrong because you didn't write it as the equation for a line. So be careful there. Bloop. Okay. Amplitude. So first thing I want to do is identify the midline. Where does that look like? Y equals 0. Very good. So I'll just count up from there. So I went from 0 to 3. How far was that? 3. So I just type a 3 and press enter. Bloop. How's this going? Is this pretty good? No big deal, right? The next one is the period. So on a situation like this where I haven't drawn the midline, I'll often just start at wherever x equals 0 is. So I'm going to go from maximum to the next maximum, right? So I started at x equals 0, and I ended at 2 pi. How far did I go? 2 pi. 2, and I'll press the little pi button down there. Bloop. How's this going? Pretty nice. All right, the next one, we're going to be filling in the equation. So the hard black one is just the regular cosine equation. So the dashed one is the one that we're going to be writing the equation for. So let's start with the midline. Looks like that's at -1, right? So I'll write -1 for k. The amplitude looks like we've gone 1 unit up from the midline right there. So the a is 1. Now I know it's +1 because if I look at the original cosine, it's not reversed. Like if it was like, you know, if this spot was a minimum instead of a maximum, I know it had to be negative. I'll just put a 1 there. And then if I look at the period, I'll start here maybe at x equals 0 at a maximum. I go here to 2 pi, which is my next maximum. If I fill in, if I solve for c, 2 pi is equal to 2 pi times c. What does c got to be? Right? And again, that could be positive or negative. It doesn't matter. And I hit try, and it said that was correct. I think when you hit try, it like plots what you did, so you can see if it like is where it's supposed to be. But that did it. You have another one of these, but they're going to get a little bit maybe more complicated, where like maybe 2 things might be different instead of like, you know, like essentially the A and the C didn't really do anything. They're just ones. Here, I think up to 2 things could be different, but it's still the same idea. I'm not going to do this. Is that okay? Okay. And then the last one is like that last example we did, where it's going to give you a midline, an amplitude, and a period, and just ask you to write the equation. Again, lots of correct answers for this. What do you guys think? Feel good? We can do this? The remainder of your time in class you can spend working on this delta math, which is not due till next Sunday, but why not just try to knock it out right now today, right? You got whatever, an hour-ish left. Like, crank that sucker out. They're not too bad. Josh?
Was the review due or no?
So the review is part of Sunday's problem set. What I'm looking for on Sunday will be the 51 through 60 problems, worksheet 1, and then the review.
Yeah, like the unit circle worksheet?
The unit circle worksheet that we started and did in class. Yep. So those are the 3 things that will be part of Sunday's problem set. Now, again, the review is, you have the key for it, so it shouldn't be too bad. You've probably already done it, fingers crossed, before you took the test. So it's basically just collecting some stuff we should have already been finished. But I'm done here,